Okay, so we've got a slightly more complicated graph here, but it's still a distance time graph. The difference here is we haven't got a straight line, it's a curve, okay? So this graph is a curve. So let's point out some of the important points about this. Well, first of all, throughout the whole 30 seconds, the distance that this object travels is constantly increasing. So that tells you that throughout this graph here, throughout the entire journey here, the object is moving because there is a gradient. Nowhere on this graph is the line completely horizontal. Now, if the graph continued, it may go horizontal there, okay? And if it went horizontal, you could say then that it was not moving. But throughout the entire graph here, the gradient is positive. There is a gradient, there is a slope, so the object is moving. However, because the graph isn't straight, we can say this. Well, actually, we can say that in the middle section here of this graph, you can see that it is straight. So during this section here, from about 12.5 seconds to about maybe there, so about 17.5 seconds, in that region the graph is straight, so we can say here, okay, that the graph, this is at a constant speed. Okay, so the object is travelling at a constant speed. Also, we can say here that it's travelling at its fastest speed. So it's travelling at its fastest speed and it's a constant speed. We know it's fastest here because that's where the graph is the steepest. Now, if you look at this first section here, the gradient becomes increasingly steep. It's getting steeper and steeper and steeper. And we know from previous work that we've done that the gradient of a distance time graph gives us the speed of the object. So if the gradient is getting increasingly steep, that means that in this section the object is speeding up. Okay, now in this section here the gradient gets less steep, its steepness decreases. So in this section from here to here the object is slowing down. Now another way of saying speeding up is accelerating. Another way of saying slowing down is decelerating. Okay, so in this section here, moving at a constant speed. In this section here, we're accelerating, and in this section here, we're decelerating. Okay, so whenever you have a graph that looks like this, we're accelerating or speeding up. And whenever you have a graph that looks like this, or a section of a graph that looks like this, whoops, we are decelerating or slowing down. Okay. Now we can look at this a little bit further, and we can say that in the first 5 seconds here, okay, so between 0 and 5, the object moves about, let's say, 12 meters. So at 0 time, the distance travelled by the object is 0. After 5 seconds, the object's travelled 12 meters. So in the first 5 seconds, we've gone 12 take away 0 equals 12 meters. Okay. In the next 5 seconds, what you'll find is we go from 12 up to about, what's that there? That's 10, 20, 30, 40, 50, 60, 10, 20, 30, 40, 50, 60. Yeah, so it's gone up to about 60 meters, but it started at 12. So 60 minus 12 equals 48 meters. Okay, so in the first 5 seconds we travel 12 meters. In the next 5 seconds we travel 48 meters, and that makes sense because the graph is getting steeper. It starts off not very steep, and it gets steeper. So we're speeding up. So because in this section we're moving faster, and in fact we're speeding up, okay, up to 10 seconds here. In this section here, we travel a bigger distance because we're moving faster and we're getting faster. Now you can go even further here. If you look at the first second here, each of these is 1 second. In the first second, okay, so in 1 second, the distance travelled is tiny. It's probably less than a metre. Okay, because this is 10, each of these squares is 10 metres, so it's probably less than a metre. Let's just say it travels half a metre. So in the first second, we're travelling 0.5 metres. If you look here then, from 5 to 6 seconds, right, we're travelling from 12 meters, so 12 meters there, up to about 20 meters. So 20 minus 12 equals about 8 meters. So in the first second, you travel probably about 0.5 meters. Between 5 and 6 seconds, which is again a period of time of 1 second, you travel 8 meters. So you can see that this thing must be speeding up, because in each second it's traveling a bigger distance. Okay, it's not traveling the same distance in every second, so it's speeding up. So because this graph is getting steeper, we're traveling bigger amounts of distance in the same amount of time. Every second we're traveling a bigger amount of distance in that individual second, so the object is speeding up. And the same can be said here. Okay, if you look between 20 and 21 seconds, so between 20 and 21 seconds, we're going from this, which is 210, 20, 30, 40. We're going from 240 meters up to 250 meters. Okay, 10, 20, 30, 40, 50. Yeah, so we've gone from 250 up to from 240 up to 250, which equals 10 meters. So in 1 second we travel 10 meters. If you look here, then from maybe let's have a little look from maybe here, which is 25 seconds. So from 25 to 26 seconds. Okay, we're going from 25 there, we're about 250, 60, 70, 85. So that's 285 meters. And at 26 seconds, we're up to 290 meters. So the distance travelled there is 5 meters. So in that second there, we went 10 meters. In this second here, we only went 5 meters. So in each second, as the time ticks along, we're travelling a smaller and smaller amount of distance in each second. So the object is slowing down. It's decelerating.